elementary transformation to ki sai ending adjoint concept jangina inverse of a matrix is ong khita to hai elementary transformation concept jangin leng inverse of a matrix zon te ding hi why ding ina intercept ding dan hemona operation khem khadi zat ding te kum gel kha number 1 na interchange of any two rows or columns hai row khat to adang khathiam ekile column khat to dang khathiam na interchange noble why a given matrix pe na interchange se ahi why nei ding china notation na zat ding hai ahi number 2 na multiplication by non-zero scalar why a row khat ya mai ekile column khathiam nana sep ding dung zu ya bangchiam khata na hik nop changina you will replace that by some other quantity why nei changa hai na notation zat ding hai dia why so addition of row or column elements to another row or column why changina leng hai sign ma na sang dia hai ya na et phot podule number 1 chi lowa we are to change any row or any column occurring in the given matrix while if you are to change a particular row that row will also occur in the operation column na ileng dan maina now if you want to change r3 then r3 itself should get involved if you want to change c2 itself should also be involved haite jam te dia example kon like dia example kon la nai ki dia then china exercise en dia hoite pansanina haite gen chang som nga ding hi haizo icham te ding ina elementary transformation kha type ni ama khatna row transformations or operations ma hey operation ding changa a relation is at ding pen kha a is equal to ia it is a non-relation ma and it is also true because I to a multiply legend I is identity matrix into a matrix will be that matrix A itself to ding dan hai dan you will perform any of these operations according to your convenience apply it on A ma hai left side A pen na apply dia why na apply kom na helama I mu som de why so helama na left side na apply bang kha ya right side I pen na apply lechin this I will then convert to some other matrix which is not I anymore no say B then you will not do anything here keep it as it is a pen kha khoi se singai lo while you will come to a relation where you have I equal to BA chile hai pang you multiply two things and you get the identity matrix chile hai A you can imply that A is the inverse of B or in other words you can say B is the inverse of A this will then be your conclusion mala ajaka matrix ni na multiply identity matrix na mo chu haiti a matrix tegel kha they are inverse of each other ai te te ngai ma else you will not be able to get the identity matrix I hai kha to a concept a logic hai elementary transformation pansana inverse of a matrix is on som changa a logic is at som pen kha to pen chet hi wai dan bang maina column transformation jangli lechin column transformation ading ina a relation na zat depend kha A equal to AI bangja ka hai a relation tom se chi le whenever you are talking of operations on product matrix the first one act as row the second one as column hai jaka row operation ade hai ki jang se bangja kin I hai pen ki khe ko dei cha mo next column transformation hai ki jang se bangja ki chi le the second matrix here in this matrix product AI I act as column hai jaka na column operation in khai pen cha usu khadi Hey pen chau su khadi jaka hey I pen kha khek di. Now in the same manner as you do in row transformation, hey ya row transformation to apply in la hey A pen kha, you will try changing it to I. In doing that, applying the same operation on this I will change to some other matrix B, AB equal to I, kibang non tama. Then you can imply that A is the inverse of B, or you can say B is the inverse of A. Hay pen khana conclusion ng paiditan ay elementary transformation concept jangina inverse of a matrix is on somale. Find the inverse of this given matrix using elementary transformation. Hemuna elementary transformation direct in it does not mention anything about row or column. That means you are free to use any one of them. We know that A is equal to IA. Hey matrix A pen ka ahi bang bang ko idadi. Hay zo gel mangil lo dia. If not, your equality will not be correct anymore. Now what is your aim? Hey, left side a matrix pen ka, we will try converting it to this one, this kind of identity matrix. In the process of doing that, this identity matrix also will consequently change, and then it will convert to some other matrix. Why a final left lama identity matrix the final outcome here, the matrix obtained here will become the inverse of the matrix A. Why dia bang? Why dia ipaiding dan to left side the identity imuna dia ka first row elements of identity demo somdi 1 0 0. Okay, now the first aim is to get 1 here. Here 1 muudi le, we will have to work along R1 ma. We will apply R1 replaced by 1 muudi na dia. Here anwa row ni omlai te bang chinai sang thi dia le. You can do dividing by 2 directly. You will be carrying along with fractions everywhere ma. So applying R1 replaced by R2 minus R1 ajak, because I will be subtracting 3 and 2, which will give me 1. So I take dikha R1 chile R1 loading. Then you will have 3 2 1 2 1 2. Right hand side 0 1 0 0 0 1 and A. Now you do this R2 minus R1. R2 minus R1 will be 3 minus 2 1 2 minus 1 1 1 minus 1 0 0 minus 1 minus 1 1 minus 0 1 0 minus 0 0. 1 muta. The next aim is to convert these 3 to 0, these 2 to 0. Why there? We will multiply this 1 by 3, subtract with this 1 to get 0. We will multiply this 1 by 2, subtract with this 1 to get 0 at this point. Why there kabang? You will now apply R2 replaced by R2 minus 3 times R1. R2 minus 3 times R1 bang hidi chile R2 hai peiting mo 3 minus 3 times R1. R1 is hai peiting 3 na multiply le chin 3 monondi, so 3 minus 3 will give you 0. The same way, using the same logic, R3 will now be replaced by R3 minus 2 times R1. R3 ji hai pating engine starting with 2 and we want 0 at this point now. So what we will do is we will multiply R1 by 2. Then 2 minus 2 will give you 0. So I hek lo diom sun kha R1 here. R1 gel khema sun only 1 1 0 minus 1 1 0. R2 hek ole R2 minus 3 times R1 0 hai tigel chun hisab sai cha solve non ke le chin le poilo mo hai tigel hisab sa hai operation ong piang ai ja ka hai first tigel ba calculate hun ba pai non ngai lo. Next, let's fill up the remaining elements. R2 minus 3 times R1. So 2 minus, this is R2, 2 minus 3 times R1. 3 times 1 is minus 1. R2, 1 minus 3 times R1. Minus 3 times 0 is 1. R3 is 1 minus 2 times R1 minus 2. 1 minus 2 is minus 1. So R3 is 2 minus 2 times R1 0 2. Toma bangina right hand side hey matrix sunga to operation tema apply knowledge na R2 minus 3 times R1. R2 0 minus 3 times R1 minus 3 plus 3. So R2 1 minus 3 times R1 minus 3 will be minus 2. 0 to 0, whatever you do, it's still 0. Next, R3 minus 2 R1. R3 0 minus 2 R1 minus 2 plus 2. And then R3 0 minus 2 times R1. So 0 minus 2 minus 2. And then R3 1 minus 2 times R1 minus 2 times 0 0. So 1 minus 0 is 1. Hey, anole. Now you obtain the first column elements of the identity matrix. Next is to convert the second column elements to the second column elements of the identity matrix. Hai dia khabang. Dena one mu masak kisom pen mo hai pen. In the same way now we will try to get 1 first here. Converting this 1 to 1 is the same as converting R1 to R2 to its negative. So now we will perform R2 replaced by minus 1 times R2. Chile R1 to R3 ki khoi khalo he chawai tigel khanon le chin 1 le R2 if you multiply everything by minus 0 hey 1 swakta minus 1 minus 3 minus 2 becomes plus 2 0. Hey non tale to 1 muta. The next objective will be to convert this and this to 0. R2 you will not change anymore. Now apply R1 replaced by R1 minus R2. Ajak hey 0 de na hile R2 at 1 umay cha 1 minus 1 0 hikin ma. And next R3 ka minus 1 replaced by R3 minus 1 plus 1 will be 0. So R3 plus R2 hey perform. Now you will not be changing R2, so write that down first. R2 is 0 1 minus 1 minus 3 2 0 and then A. R1 R1 is now R1 minus R2 1 R1 minus R2 1 minus 0 1 minus 1 0 0 minus minus 1 plus 1. So R3 is R3 plus R2 0 plus 0 0 minus 1 plus 1 0 2 plus minus 1 is 2 minus 1, which is 1. Perform the same thing on the right hand side. R1 replaced by R1 minus R2. R1 minus R2. Minus 1 minus minus 3 is minus 1 plus 3, which is 2. 1 minus 2 minus 1 0 0 0. Next, R3 replaced by R3 plus R2. 2 minus 3 minus 1 minus 2 plus 2 0 1 plus 0 1. Now you can see here second column now converts to the second column of identity matrix. To Alaska, you will have to change this column to this column of the identity matrix. Identity matrix third column to kibat sakdi itama 1 omna pen 1 mu masak pen som non ding 1 hi kinta boy pi ngai lo chi le to 0 convert ngai tama. So what you will do is R1 replaced by 0 ana he ku le zanga pen 0 na he na dia bang chi di chi le you will subtract them more. So R1 replaced by R1 minus R3, R2 replaced by R2 plus R3, R2 minus 1 plus R3 1 minus 1 plus 1 will be 0. Okay, so R3 ki hoi khanon loi cha R3 get masanon le china 0 0 1 minus 1 0 1 and then A. Now R1 replaced by R1 minus R3. R1 minus R3 1 0 minus 0 0 1 minus 1 0. So R1 minus R3 2 minus minus 1 is 3 minus 1 minus 0 minus 1 0 minus 1 minus 1. Next R2 plus R3 0 plus 0 0 1 plus 0 1 minus 1 plus 1 0 minus 3 minus 1 minus 4 2 plus 0 2 0 plus 1 1. Now this is identity matrix, this is some other matrix, and A carries alongside. So now you have come down to I equal to BA. That means if you multiply a matrix B with the matrix, the given matrix A, you get the identity matrix. B ka A inverse otherwise B pen A inverse you will not be able to get I. Therefore A inverse is equal to the resultant matrix here 3 minus 1 minus 1 minus 4 2 1 minus 1 0 and 1. Aida naka inverse of matrix using the concept of elementary transformations. Hemuna thi tuak non khata hi le row operations ki jangin chin transformation ka it is happening along the column. Mala heya operation ting ting ka row ngen hin chin hilele transform tena cha ka first you are transforming the first column haizo second column ang ki hek non in chin haizo third column ki hek non ma sile take talk to row operation nazarle transformation will happen along the column. If you use column operation, transformation will happen along the row. Bana hemuna take loading row operation nazar ngi le affect sip sipa row operation ngen ngen hi di na operation ting ting om namuna You cannot mix up row and column transformation. Why chạm tới này nhá. You cannot mix up row operations and column operations in finding out the inverse of a matrix. Hỏi đàn here column transformations le ma hỏi pen kha no na ki try diu na azia kai le row operation aphi lamai lak ting ting kha asuk lama lak di mai ya akilam dan lo nam lo mai ban a haksat lo na lem ton lo ya na ki try le chin